Hi, my name is Dale Maley. In this short video, I'm going to explain how to figure out the operating speed of a wood model and what kind of cranking speeds you should have for wood models and toys. Just a little background in my experience. I've designed and built over 40 hand-cranked wood models, and I've also designed and built seven larger wood models. And I have 8 grandkids. Plus, I take these models out for public display, so I have adults operate them too, so they get used and abused quite often. One of the key elements in designing hand cranked models is the operating speed of the model and the cranking speed of the model. In this short video, I will explain to you how I do this. Now let's define some terminology. So you have the hand crank, which goes at a certain RPM or speed. Then it typically goes into a gear mechanism, and you have a gear reduction ratio which slows down that speed. And then finally you have the actual operating speed of the model itself. So with respect to speed, or RPM, the two key inputs to designing a hand crank model or toy, one is the maximum RPM that it will operate at. A lot of models will not operate at higher speeds. Then what's the maximum RPM or max speed that a child or an adult can hand crank the model? And once you know those, you know what the gear reduction ratio needs to be, which in my case is usually wooden spur gears or wooden worm gears. So there's really two ways to figure out the maximum RPM the model will operate at. One of those is to calculate it. But most of my models are fairly complex, and it would be extremely challenging and time-consuming to try to calculate the maximum speed. So what I end up doing is actually building just the key parts of the model, and then run some tests, and then see what the maximum RPM is that the model will run well at. Once you know that max speed for the model, you can design the gear reduction ratio and figure out the spur gears and the worm gears. Once you figure out the max speed the model will operate at, the only other thing you know is what's the max operating speed that a person can hand crank the model. Once you know that, then you have the gear reduction ratio. So a key element is, how do you figure out the maximum speed or RPM that a child or an adult can hand crank a model? Now back in 2021, which is, since this is 2025, that's 4 years ago, I did some very limited testing. So I hand cranked a little model called the Kissing Cousin model. I actually have a YouTube video about that little model, but it has a very small crank on it. And at that time I found the normal hand cranking operating speed was about 100 RPM. But on later projects, the years after that, I assumed that deadly word that the max speed a child or an adult could crank a model was 100 RPM. And I use that to design models. But then quite often my grandkids could crank some of my models so fast they actually jammed up the model or they wouldn't work properly. And I wondered, why is that? So in December of 2024 I discovered my incorrect assumption because I went back to some old computer files I had, and I had incorrectly assumed that 100 RPM was the max speed that an adult or child could run a model. So then the question is, well, how do you actually measure it very accurately? And you're really going too fast to count revolutions against a stopwatch. And then it dawned on me, why don't I just take a video of myself hand cranking at the maximum speed and then play back that video in slow motion and then count the number of crank revs I made, and I can get the start and stop time from the video. So that's what I did. So the first test I ran, where I tried to crank as fast as I could, I used a non-rotating crank handle. That just means the handle's fixed, and it's kind of hard to turn because the handle's not going with your hand. Anyway, I played back the video in slow motion, and I made 23 crank revolutions in 7.25 seconds. So if you do the math, which is shown here, that works out to 191 RPM. So my incorrect assumption of 100 RPM that I made 4 years ago was only off by a 2-to-1 factor. So after I ran that first test with a non-rotating handle, I thought, what the heck, Probably go a little bit faster if I have my my rotating handle. So I did a second video using a rotating handle, which is what I use in my models. And I actually went 6% faster, or 202 RPM. Here's a short video of me cranking as fast as I can go. So let's look at an example project, a fictitious one. We now know that the max hand cranking speed is 202 RPM. And let's say that we build a model and we play around with it and we find out about the maximum speed it'll run at good is 12 RPM. To find the gear reduction ratio, you just take the 202 and divide it by 12, which comes out to be 16.83 gear reduction ratio. And I'd probably round it off. I'd probably pick a 16:1 gear reduction ratio for that particular fictitious model. To build one of these models, you've really got two choices for how to reduce the speed or the gear reduction ratio method. One is plain spur gears, but 4:1 is about the biggest gear reduction ratio you can get. And for example, you'd have an 8-inch spur gear mated with a 2-inch spur gear. So most of my models I'm using worm gears, and on a worm gear the gear reduction ratio is determined by the number of teeth on the mating spur gear. But about the minimum number of teeth you can have on that spur gears is about 6, so the minimum ratio is about 6:1. It's just very hard or impractical to make a spur gear with less than 6 teeth. Most of my models are using worm gears with 16 to 40 teeth on the spur gear. So if you're wondering how do I make wooden spur gears and worm gears, I've actually made other YouTube videos about how to first design them in SketchUp, and then I have other videos on how to make them. Now in the case of worm gears, you don't have to design it first in SketchUp. My method doesn't rely on that. But anyway, you can look at my other videos for how to make these gears. It takes about an hour to make a 4-inch long worm gear with a 2-inch outside diameter. One of those recent ones is shown up there. And spur gears are much faster. I can probably make one in about 15 minutes. Now for some closing thoughts on this little video project. I was really surprised that I could actually crank up to 200 RPM, and I've been incorrectly using 100 RPM as the max speed that a child or an adult could crank one of my models. So it's no wonder that some of my grandkids could crank some of my models so fast that could cause them to jam up. So I will be using the 200 RPM max hand cranking speed when I design future models. So in summary, this short video explains how I find the operating speed and the cranking speeds for the hand crank wood models and toys that I build. You can see my many other videos about building model toys, hand crank models, and other videos. And I hope this video helps you on your projects. I hope you enjoyed the video, and please subscribe. Thank you.